thank you, Nick, for being here and for taking time out of your very busy schedule. We really appreciate it.
Oh, it's my pleasure. Thank you.
So we had Thomas Edison, who went and invented really, the electric bulb. And to make that successful, he actually had to have a vision. The vision was that he had to have centralized grids and actually a network which takes power from point A to point B. And then we had several industries that came up following that vision and building components along the way and managing and operating those grids and so on and so forth, right? There was that invisible hand and the vision of Thomas Edison to make it happen. In cloud computing, do you see that invisible hand and that vision?
I do see a similar process working. I don't think I don't think you have the kind of central visionary like Edison was in the early stages of the electric utility industry, but I think in a more distributed way you see visionaries emerge in cloud computing. In Edison, as you said, Edison's great. We tend to think of Edison as an inventor of particular products, light bulbs, phonographs and stuff, but his greatest strength was that he was very much a systems thinker. So he didn't, as you say, he didn't just invent the light bulb. He had to figure out, in order to get this light bulb to work efficiently, I have to create a complete distribution system for electricity. And as it turned out, though, in a way, Edison's initial model wasn't the model that won in the marketplace, because he was focused on distributing DC power, which couldn't be transmitted very far, so it meant everybody had to, every company had to build their own electric generating station in their own company. And of course, Edison built his kind of conglomerate of companies to supply the plans and the components and the expertise to help all these individuals build, or individual companies build their systems. And ultimately, that kind of fragmented model got replaced by the alternating current AC system. That's went a further step in centralization, said you don't have to run your own generators, we'll run them centrally. And I think we're seeing a very similar thing now with cloud computing. We're kind of, in a way, we're in the Edison stage. And you see this with private clouds, for instance, with lots of companies building their own utility computing center, data center, or having somebody else operate it for them or whatever. Very much the model, the Edison model, build your own generator. And at the same time, we're seeing the build out of the public grid, the shared grid. And again, this is something we saw in the early stages of the electric utility industry. So I think we're going through the same kind of transitional period where private, cloud computing plants, private clouds, will be popular for quite a long time, but increasingly over time, more and more of these services are going to move to the grid.
That's a great point. So we're talking about Edison as being a systems innovation person. We're talking about workable systems that can work together. In your experience, based on the interviews you've taken, and you've spoken to advisors and CIOs, and you're speaking to a lot of experts in the field, do you think that they are working towards a common workable system?
I would say no in many cases. I mean, the way cloud computing is developing, and again, this is common, is that different suppliers and different users look at this as a set of tools to do particular things. And so we're seeing great progress in particular, software as a service applications, particular models of utility computing, utility services, storage, compute cycles, and so forth. But a lot of this innovation is still taking place in a fragmented way. And again, this is something we saw with electric utilities, where you had, in the early years, you had, lots of different standards across the country, and certainly we still have them across the world, but even across the United States, there are all sorts of different standards depending on local utilities, different appliances that would work with these standards. And eventually, it was only after the industry, both the appliance makers, which are kind of analogous to applications makers today in computing, and the grid, the companies maintaining the grid, the utilities, got together and said we need to have standards, interoperability, standardized interfaces and everything. And once they did that, that's when the electricity utility industry and all the appliance industries that were built on it really exploded. So I think that's going to be one of the big challenges in cloud computing over the next 5 years or so. It's how do we think of this as a unified system? How do we set the right standards for interoperability, for data transfer? How do we create interfaces that allow us to integrate all of these, now fragmentary services? And that's going to be that's going to be a necessity for really getting all of the promise out of cloud computing. And B, it's also going to be at a practical level a big area of competition among IT suppliers, and a big worry, I think, in many cases among the users of IT, because increasingly they're going to want more integration, more standardization, more interoperability.
Mm-hmm. Great, Nick. So thank you so much for your time, and all the best for you afterward, and we really appreciate your insight and your comments.
Thanks very much, Anubhav.